I got to know whose it is if I want to give credit.
My glasses broke, so I had to get some new ones.
Oh, did you?
Yeah.
They look pretty much like your last ones. Are they real similar?
Yeah, the green. It was like on the green, but now it's red.
Yeah, it's red now. All right, I like that.
And these glasses don't fall off like last time.
They're
so wobbly.
Yeah, that's no fun. Wobbly is not
I
good.
was trying to play around with my grandparents.
Yeah.
But my glasses fell off and broke.
Oh no. Are your grandparents visiting?
Yeah.
Come see the baby? Come see the baby? These are the ones that live in India?
Yeah.
Do all your grandparents live in India?
No, so.
Who's living in India? Your mom or your dad?
My maternal.
Okay, so your mom's family lives in India. Where's your dad's family live?
Somewhere up.
In the US though?
I think so.
Oh, okay, all right, but not in Georgia, not locally. Do you have any family locally?
Yep. No, wait. I have some family living in Virginia and in New York.
Where in Virginia?
I don't know, but I know we visited them.
But nobody here, like in Georgia.
Yeah.
No cousins or anybody here to hang out with. Yeah. Yeah, all my boys' family's in Virginia, so. I like Virginia, born and raised in Virginia, it's a nice place.
It's getting hotter outside.
Yes, it is, it's gonna be
I don't know why isn't the pool open yet.
Your pool's not open yet?
No.
I think ours is gonna open real soon.
Yeah, ours is gonna open in summer.
Yeah. Ours should be open pretty soon, because they do a good job of trying to open it when school wraps up. So we've got our dance this weekend. Y'all are coming to that, right? Yeah, so. We had our dance on Friday, that's gonna be fun. So we have all the dance stuff is spread all over the.
Who's coming for the dance?
Many other people. Most of this class is coming. I'm trying to see, who do I know? I know James, Emma, Jack, Emma's brother.
Are Lewis and Darcy coming?
Did not see their name on there. Or the Nico and Carlos. All of the Bensons. So PJ and Bailey and then Alex too. And then who else? Colin, I think. Yeah, James and Caitlin. Drew's bringing his girlfriend. Milo and Chloe. I don't think Williams. Parker from last year. Trying to run everybody through my head who's coming. So, it's going to be fun.
What's in the dance? What are we gonna do there?
So we have it at the clubhouse at the front of my neighborhood. We just have food and we play pretty much requested music all night, whatever anybody requests, and then the kids dance all night long.
All night?
Yeah, for 3 hours from 8 to 11. We dance and have fun. It's a good time. They always have fun, and that's what we want. We just want people to have a good time. Because there are some homeschool dances, but a lot of them tend to be like, at least when I started this dance like 6-7 years ago, a lot of the dances that I kept seeing were themed. It was like, it's a Christmas dance, so people would go dressed in Christmas colors and stuff, or it was a Halloween dance, everybody would go in like costumes. And I was like, can we just have a normal spring dance, just a normal dance, you know? So I made up a normal dance, so we have a normal dance. And it's fun, it's a way for homeschoolers to get an opportunity to do something that like public schoolers kind of take for granted, right? They do it like
Is it in
twice a
the
year.
like? Is it when you're entering your community? Is it in like the club?
Yeah, by the pool.
Yeah,
it's right there. It's a big room. That's a big wide open room. Pictures of it here. It's a big wide open room, and it works out well because it's a nice space.
Oh, aren't we gonna do the Jeopardy?
Oh yeah, we are.
Yeah. I wish I'd be in another team besides Lewis. He amazing.
You guys are gonna do great. You guys are gonna do great. Let me see if I can get it to load. Hello, load. Where's my stuff here? Uh-oh, is
So
my
it's
internet?
kinda laggy, pretty.
Yeah, it seemed like it was for a minute there. Let's see.
Switching to annual.
Mhm.
Is that dance?
No, I don't know what that is. That's just somebody's, that's just in the feed. There we go. There's all the stuff from this year. But there should be some videos and stuff from last year on here.
Yeah, there's a video on top.
Yeah, that's an ad that I did. That's an ad too.
You create the annual homeschool spring dance?
I did. Well, there's video in this ad though. Like, let's see.
And then relationship. And that will have S me that.
Looks like that.
Yeah.
Is there a picture of the outside?
No, not in this.
Exactly.
So you have to pay to come to the dance?
Yeah, the ticket says $20. It covers all the food and the rental. You have to rent the building. Let me see. I have a picture of the outside. There's the outside right there. Yep, looks like that.
Yeah.
And we have accents on this, right?
And these are pictures from previous years. See, we put out all kinds of food. Yeah, we put out a big spread. All right. Dancing, dancing. It's a lot of
The
fun.
dance will last for 3 hours?
Yeah, it's from 8 to 11. See, food.
If my little sister were there, she would have been asleep.
I'm sure. Good morning.
You still broke your glasses? Yeah. Well, it's not a big deal because I also broke.
But see, it's a big room. See the big room? It's a lot of space, so.
What is that?
That's where we have the dance. The dance is on Friday. I don't think y'all have tickets. Are you gonna come? It's so fun. It's so fun.
Around like this whole space, the dance.
It's bigger than this space. It's real big. But it's not too big. It's not so big that you get there and you feel like, oh my goodness, I don't know what I'm doing or where I am or whatever. It's a good space. And then there's like a wraparound porch outside. So some people will go outside to the wraparound porch area and just kind of hang out there. Are those yours? Those didn't have a name. I don't know whose those are because there's no name on them. Okay. I wanted to award you, but I didn't know who to award.
I always put my name on the back. Is that yours?
Yeah. Come on,
Why are
close.
there so much pencils and stuff?
Why does it do like this? Sometimes it doesn't like to close.
Danny,
Yeah.
pencils and accessories and stuff here.
Oh, I don't know. If you find them, just pull them on out, toss them on the table or whatever. People just do that. I don't know why. They just forget them. They just forget them there. Yeah, if y'all are interested, the dance is gonna be on Friday.
I found
And
the
it's
list.
at the courthouse, at the front of the, thank you, at the front of the neighborhood. And it's, if you go online and you can go to our website, that's where the tickets are. If you buy the ticket on our website, it's only $20, but if you wait till you come to the door, it's 25. And then we have food, it's 8 to 11 on Friday. Most people dress up a little, but wear what you're comfortable in, right? Come and have a good time. We have tons of food, water and lemonade, and then like this year we're gonna have, let me see, we have barbecue meatball shooters and buffalo chicken shooters and like a charcuterie. And we've got, something else I'm not, oh, bagel bites. Everybody loves those. That's like a favorite. And then we've got, chocolate pudding parfaits and vanilla berry parfaits. They're all like little mini cups with little mini spoons. It's kind of fun. And then mini cupcakes. And, that's most of the desserts and stuff. But it should be lots of fun. It's usually a really good crowd.
We have a ribbon.
You want?
We have a ribbon.
Oh, you're ribbing. Did you figure out how to get stuff out of it yet?
Yes.
Yes, okay. We can unload the truck now. It's official. What color is yours?
Blue.
Is it like that kind of like a not metallic?
No, it's like a dark
I
teal.
love that color. I've seen that one, yeah.
It's not.
It's just.
Y'all had somewhere to be Friday, right? Like you have a trampoline competition or something? That's why you weren't doing the dance? I thought you had something that conflicted with the dance on Friday.
I think it's a gymnastics. Friday, I had to go to a golf tournament.
That's what it was. You
Yeah.
had golf.
Oh, he came first in his.
How about flying?
Outstanding. Very good. Congratulations.
I was left on my own.
Long 2 days.
Oh, yeah? Well, all right, if you can come to the dance, come to the dance, because although it's like not technically part of this class, I use our website and all of our stuff to do it, so if there's any leftover money, I put it into our class budget usually, so it helps pay for things, so I'm trying to get some stuff for chemistry next year that should make it,
Countertop. dish.
I want the countertop dishwasher,
You
man.
do Jeopardy.
We are, so we're gonna roll through this week's lesson
Where's
real
the-
fast, and then we're
I've
gonna
been
do.
preparing in the car for Jeopardy. I got
All
my
right,
stuff.
and then we're gonna do Jeopardy, so,
Danny,
yes.
can I steal Emma's chair?
yeah, of course.
Steal.
She's gonna come in and be like, wait a minute.
Do it quick, run.
We all slum it on this couch.
There you go.
Emma's chair.
Slumming on the couch.
Okay. Okay.
It is a very
Then I'll
comfortable
steal
couch.
it.
I like it.
I now got
I'll
my
do it.
Nico.
You know, this one's actually a sofa bed. This one pulls out. Although
Oh
we've
my
only
gosh.
ever pulled it out
We
like
have
twice.
An orange couch that used to do that. I
Yeah?
tell you how much slime I spilled on that.
All right, let's go fast through this lesson so that we can get to our Jeopardy review. Okay, are we ready? Pages are opening.
This one's 32.
This is 32, man. We are nearly done. Well, we are done. This is it.
31 homework wasn't that big.
Yeah,
I need to study for the test.
yeah, yes, you do.
I am studying for the test. I'm in the process of flashcards and I've written down everything on the slides.
Atta girl.
in My book.
All right, well, let's roll with this. Okay, so properties of solutions is what we're going to talk about first here. All right, a solution, it consists of a homogeneous or homogeneous, some people will say mixture. A solution is composed of one phase, either solid, solid, liquid, liquid, gas, gas.
I got my retainers.
Oh, okay. Particles in a solution are not visible to the naked eye. Solution does not scatter a light beam. Components of a solution cannot be separated using simple mechanical filtration. So what is dissolved? Okay, Darcy,
Sullivan?
the what?
The Sullivan?
No, that's the other one. Nico?
It's a solid.
Solid is dissolved, and then Darcy said what?
Sullivan.
Solvent, right, your solvent is what
I was
is,
focusing on the bottom one.
does the dissolving. So your solvent does the dissolving, it dissolves the solute. All right, so here are some examples. Air is a solution, it's a gas example. You can have some that are not all the same phase. For example, you can have gas liquid like carbon dioxide and soda. You can have gas solid, which is like hydrogen gas that is in palladium metal. You can have liquid, that's gasoline, solid liquid, sugar and water, for example. Liquid solid, mercury in dental amalgam, yep. And then lastly, solid is sterling silver. Okay, we don't use mercury in dental fillings anymore. Why not?
Because it was like causing bad.
Because it's what?
Because it can cause fire.
It's toxic. It's poisonous.
It's giving you like oral cancer, I think.
It can cause neurological damage and things. So yeah, but anybody who has like really old silver fillings, they usually have them removed and replaced. The new amalgam, which is the new silver fillings, they're not actually silver, but the new amalgam doesn't have doesn't have mercury in it. And then usually what they're using now a lot of the time is the composite, which is the white stuff, right?
Yeah, that's what I got for mine.
I had a dentist tell me that his favorite thing to use for fillings is actually gold, because he said gold wears down at the same rate as natural enamel. And the problem with composite fillings is they're weak and they crack and they fall out and have to be replaced every so often. I've already had some replaced. And these amalgam ones, the silver looking ones, they're very rigid. So man, think back to when we talked about tools. It's like a wedge in your tooth. So every time you bite on it, it drives it into your tooth and it can cause your teeth to crack. So that's why people sometimes get gold, although it's usually cost prohibitive, you know. All right, acids and bases. All right, acids turn blue litmus paper what color? Do we know, Lewis? Yeah, pink, red. And then bases turn red litmus paper what color?
Purple?
Do you know? Yeah, it's like a blue. All right. And then acids give off H plus. That's a hydrogen ion, a positive hydrogen ion in water. Hydrogen. That's easy. What's this one? What's OH negative? It's what bases give off when they're dissolved in water. Does anybody know? That's hydroxide. We'll see that a lot next year. So you have an OH negative when you put a base in water. Acids generally taste how?
Sour?
Yeah, they taste sour. You've had an acid if you've
Sour
had
due-
vinegar, right?
Sour due, is that a brownie point? Sour due to the sour age?
Yeah, well, that's what makes them taste sour. That's what's causing it.
That's nice.
And then how do bases typically taste? Do we know?
Sugary?
They taste very bitter, right? And that's due to the hydroxide ion, but they may have other tastes depending on the other parts of the molecules, right? Depending on what's in them. Okay, acids corrode something. Do we know what they corrode? They corrode, click, metals. And bases denature proteins. Okay, so proteins are denatured, which basically means they're broken down into their constituent parts of amino acids. That's what bases do, okay? And bases are usually soapy in nature. So you can think of that as being kind of a, we'll come to a minute. You can remember this in a minute because it might come back. So acids have a pH less or more than 7. Do we know?
More.
Who says less? Who says more? It's less than 7. And then bases have a pH of greater than 7. There we go. All right, now, when you dissolve an acid or a base in water, it makes what? We just saw them, hydrogen and hydroxide ions, right? And that is what makes it conduct electricity better. So the stronger an acid or a base, the more ions that are produced. Yeah. So the conductivity of the solution increases. So if you have a solution with water and an acid or water and a base, it's going to be more conductive than water by itself because it's going to release either hydroxide or hydrogen ions. So when an acid reacts with a base, what do they form?
Ion.
Think about it. What happens when you put, what is it, Lewis?
Gas.
Yeah, you do. You get a gas and also a salt too. It's usually you get a gas. You're right. Because when you put vinegar and baking soda together, you get a gas and a salt. Yeah. So they both carry and share ions. All right, now we're going to play a game. We're going to go down. So milk, wasp and bleach. So we're going to vote. Is milk an acid or a base? Who says acid?
Base.
Who says acid? Raise your hands. Let's vote. Okay, who says base? Acid or base? It's an acid. Oh, are you surprised?
Oh, it's sour because when it goes off, it tastes like.
Yeah, that's true. It does. All right, wasp venom. Who says acid? Who says base? It's a base. How about bleach? An acid or a base?
Bleach is definitely.
Acid.
Bleach is a base. Now, mango, acid or base? Acid. That one's easier, right? Yeah.
It's vinegar like surprise.
Vinegar, we all know, is an acid. How about lye?
I don't know what that is.
Base.
It's a base. Lye is used like as an old cleaning agent. We don't use it as much anymore because it's really, really like strong. Bases can burn your skin and cause reactions just like acids can. Like a strong base is just as bad as a strong acid. Drain cleaner in particular, like, you know, the stuff you poured like Drano,
Oh.
that's a really strong base. It's not an acid, it's a base,
I
but
think
it can
the
hurt
next
you.
three are
You think
acid.
about like acids being what dissolves your, you fell into a vat of acid and your skin came off it.
Definitely.
Yeah.
Oh, wait, no.
Apple, acid or base?
Acid.
Acid is right. Spinach, acid or base?
Acid.
Base. Pineapple, acid or base?
Acid.
Acid, that one's easy. Soda, acid or base?
Acid.
Acid. Hand soap,
Base.
base. Lime as in the kind you eat?
Acid.
Acid, okay. Baking soda,
Acid.
Base.
base. Window cleaner.
Acid.
Base.
Yeah, this depends on your window cleaner. If you're using like over the counter stuff, but a lot of people make their own window cleaner out of vinegar, right? I do.
Yeah.
All right, stomach juice.
Acid.
That's an acid. What kind of acid is in your stomach?
The one that dissolves.
Oh wait, like like the thing. If you pour it in a cup, it can break.
Yeah, it's actually hydrochloric acid that your stomach produces.
Drain cleaner.
Crazy. And then drain cleaner, I said was it's a base. It's a base. Okay, so how do we, isn't that weird? So how do we identify pHs? We use something called an universal indicator, and we have a bunch of these that we can use. And in particular, one of the more common ones will show you like a rainbow of color like this. And I actually did this once where I made a rainbow of test tubes. It was the last time I did this class because we were all online. So I had to do something because we couldn't even do a lab. So basically we all kind of watched the colors change, and then I told everybody what the chemicals were. So universal indicator is actually kind of brownish orange, right? And when you add it to a solution, it'll turn a color, and that tells you what the pH is. There's other indicators as well. We'll be using next year in lab, we'll be using phenolphthalein a lot. That is like a hot pink, like a screaming hot magenta pink color. And that's a fun one to use. And we'll also be using bromothymol blue, a couple of others. It's really cool.
Have you ever dyed like a white flower?
Oh, like putting it in with food coloring and water?
You cut the stems in half.
Have you ever done
Yeah, that's great. You can see where all the vascular systems in the plants go. All right, so that's the end of this very quick lightning speed lesson. So now what we're gonna do is I gotta do.
Are we gonna end this?
We're I don't know where they probably sent me a message and I just don't see it because I'm over here working, but let me let me switch this real quick and make sure that we
Are
all,
we done with the bunch?
yeah, unless you have notes in there that you want to be using.
Can you notes? No. I don't have any notes in here, unfortunately, but I memorize all of the big scoring questions.
All right, now. So we're gonna do two teams. We're gonna have a team of two and a team of three. So,
Us two versus.
all right, we'll do
We'll be
you
together.
two,
We'll be together.
you three. So Darcy, why don't you hop over here to Carlos?
You wanna come?
Yeah, sure.
Okay, we got three over here and two on the couch. Oh, did I? No, I kicked it or something. Let me make sure it's good.
The computers.
Okay,
I'm just gonna.
listen, huddle.
There we go.
Don't say the.
We pick what we go for?
Yeah, you're gonna pick.
Okay, I know.
So,
We go first.
since I was gonna say, they have two, so I'll let them go first. So here's the way it works. They get a chance to answer the question, and if they get it wrong, they get it wrong. We're not gonna move it over to the next team. Okay, so if they get it wrong, they lose the points. Yeah,
Is the final longer than the midterm test?
a little bit. I'm gonna tell you guys what's on it.
Move it 900.
Okay, move it, 900. All right, so dudes on the couch. This is the force that opposes the motion of objects that touch as they move past each other. Team number one, what's our answer? Form of a question.
What is friction?
That is correct. What is friction? Very good. All right.
Okay, you got this.
Team number two, where are we going?
Name that scientist, 900.
Name that scientist for 900.
Darcy.
This dude hung frog legs on his fence as part of his bioelectricity experiments.
Luigi Galvani.
Form of a question.
Who was Luigi Galvani?
Right. Who is Luigi Galvani? So you get that point, and now we're moving back over. Team number one.
I need work. 900.
900, work, 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 work. When discussing the work done by a lever, sorry, there's a typo. The load may also be identified by this term.
Can we steal?
No,
What is?
Wait, can we steal? Like, if they don't know, can we steal?
What is pulley? What is it? Pulley?
Can we steal?
no, no, you can't steal. This one is what is effort. If you were asked to diagram,
Oh, that would have made a lot of sense.
yeah, yeah, because you got that one wrong.
Let's go.
So if you're asked to diagram, you could put load or effort. I will accept either answer. Okay, team number 2.
Surfs up, catch a wave 900.
Surfs up, catch a wave for 900. The frequency of a sound wave determines this in our perception. Answer in the form of a question.
What is pitch?
What is pitch? This is correct.
She did all of
Very
it.
good. She is prepared. That's what I like. This is why Darcy is definitely ready to move up next year to lab rep level, because she's doing it. All right.
Oh, we are not.
What's up?
Name that scientist.
Name that scientist for 800. The unit for measuring electric potential is named for this Italian.
Let me steal it.
They're thinking hard.
Familiar Pascal. Wait.
Electrical potential.
Who is Alexander? No. Who is?
Na, 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 na,
If it
na,
runs out, can we steal?
na, 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 na. You give up? Who is Alessandro Volta? Oops, sorry, wait, that's supposed to be down. All right, there he goes. That's down one. All right,
Who is?
It's electric 900.
it's electric for 900. In this force, opposite poles attract and like poles repel. Darcy,
What is magnetic force?
what is magnetic force? And hang on. All right, you boys, what's up?
Science matters property 900.
100.
Potpourri.
900.
Potpourri. Not potpourri means it's a little mix of whatever.
Right now.
900. In an experiment, this is what you change.
Gosh.
Yeah, go for it.
What is the control?
No.
No.
What
What
is
is what is the
Oh, oh,
responding variable?
yeah, don't answer for them.
What is the manipulator?
There you go. What is the manipulated or independent variable? All right, I'll let you have that one. All right, good deal. You're on the board. You're on the board. All right, team number 2.
Name
Name that scientist. No, I like to move it 800.
I like to move it 800. A push or a pull on an object is measured in this unit.
What is a Newton?
Let your other team members answer too, but yes, what is a Newton is correct.
Yes.
Because a push or pull on an object is what? A push or pull on an object is
Measured in
a force, and force is measured in newtons. All right, team number 1, where are we going?
It's electric 800.
It's electric for 800. If you are walking around in socks and you get zapped by a doorknob, you've experienced this.
What is static electricity?
Yes, static discharge. I'll take it. Good. Way to go. All right. Team number 2.
What do you guys?
So 900, 800.
Work, 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 work for 800. Its rate is power and its SI unit is joule.
What is work?
What is work? Very good.
What?
I don't know. All right. Where are we going?
Surf's up, catch a wave 800.
Surf's up, catch a wave, 800. The wavelength of a light wave determines this in our perception. This is the one that goes hand in hand with frequency of a sound wave, determines pitch in our perception. Wavelength, what do we perceive? You can do it.
What is color?
What is color? Very good. All right. Yes. Team number 2. Potpourri. For 8, science matters.
No, 100.
200 grams is equal to this many kilograms.
What is 0.2?
What is 0.2 kilograms? Very good. Very good. Now, this is not, I will give you a hint. Wait, pay attention. This is not the exact question on the test, but it is this type of question. You're gonna need to do this type of conversion, which all of you should know how to do. All right, team number one, where are we going?
Science matters, appropriate 700.
Science matters, potpourri 700. This is the formula for density.
Oh, ooh,
What is it?
what is mass divided by
You got it.
mass divided by this? No. Mass divided by weight?
No.
Wait.
Close. No,
Pass, please.
no, you're real quiet. Hang on, let him think. Try and visualize the triangle in your head.
Mass. Wait. Mass divided by matter.
No, you're close. Volume. Mass divided by volume. That's right there, yeah.
You can question people who don't
I
know.
think that's like 700.
Name that scientist for 700. This Serbian-born scientist championed AC power. Do it. Who is Nikola Tesla? Very good. Outstanding. All right, team number one, where are we going?
It's electric 700.
It's electric for 700. This is the process of transferring charges between objects that touch.
It touches. What is,
So if your electricity is moving between objects that touch,
what is static?
not static.
I do know.
What is electric? Wait, is that?
Hard. Thinking hard.
No.
Help him, Nico.
Good question. I'm thinking.
It is conduction. Conduction. Okay. Team number 2, where are we going?
We are going to, I like to move it 700.
I like to move it 700.
Wait.
This is the ratio of the distance an object moves to the amount of time the object moves.
What is speed?
What is speed?
I show speed.
Very good.
All the easy ones.
All right, team number one.
Work. 700.
Work. 700. This is the ability to do work. What? There we go. Very good. What is energy? Outstanding. All right. Team number 2, where are we going?
Surf's up, catch wave, 700.
Surf's up, catch a wave, 700.
Still below.
Shh, wait, bring the volume down a little. Hang on.
White light.
When combined with in equal amounts, red, green, and blue light produce.
White light.
What is white light? Yes. All right. Very good. Very good. Team number 1, where are we going? Name that scientist 100. Prior to his death and burial at Westminster Abbey, this English scientist was knighted by Queen Anne in 1705. How moving. Who is Sir Isaac Newton? You got it right. Good job.
Name that time. 600, name that time.
Name that scientist for 600. He developed the first periodic table.
Dmitry Mendeleev.
Who is Dmitry Mendeleev? Very, very good. All right.
You learn everything up to 600.
Where are we going, boys?
I like
Surf's
you.
up, catch a wave, 100.
Surf's up, catch a wave, 100. Light travels both as a wave and as these particles.
It should be easy to
What are the particles called?
What? Darcy.
Let them answer.
What is?
Okay, so.
It's little packets of light, little parcels, little packets of light.
Not iron.
Starts with a pH.
What is phosphorus?
No, that was.
Not photosynthesis.
It's got photo in it. You're right. That's a root.
Oh, God, elephant.
What is proton?
You got it.
Yes.
Outstanding. I knew you'd get it. You just needed to dig it out of your brain for a minute. All right, team 2.
I like
to
move it 600.
I like to move it for 600. This is the force that acts between any two
What's
masses. What is gravity? He says. There you go, and you are right.
Wait, it's so on 600. It's so hard.
All right, you guys pick.
It's electric 600.
It's electric for 600. These are often used as semiconductors. What are they? It's on the periodic table. It's a group.
Oh.
Or not really even a group, technically speaking, groups. Collection of elements.
It's not noble gases.
Mm-mm. They're in a diagonal line. They're in a diagonal line that goes kind of like this.
There's only one.
In between the metals and non-metals, they kind of swing down.
No idea.
Do they go like this or like this?
They go like this.
She just.
They're in a diagonal line between the metals and the non-metals.
Metal? What is? It's not
Say
noble
it.
gas. It's not.
You're almost there.
What is metal?
Yeah. Yes. What is a metalloid? Yes. Don't get too loud. We got mom downstairs listening to you thump and Jason upstairs listening to you clap. All right. Let's do it.
Work, 600.
Work. 600. This is the number of times a force exerted on a machine is multiplied by the machine.
What is the atomic number? No.
No.
What? Oh shoot, I don't know this one.
What is the number of times the force? Please get this wrong. So
What is-
his points? What is? Oh, I knew it.
Oh.
Big number.
No, it's not.
Mechanical advantage. They're excited you lost one. All right, boys, what's up?
Okay, really.
Science matters.
Potpourri, 600. In a closed system or reaction, matter like mass is all, oh, that shouldn't say or. Reaction, matter like mass is always what? In a closed system. What happens in a closed system?
Always.
What happens in a closed system? Matter and mass is always closed system or reaction. Actually, that makes sense. Matter like mass. It's a law of something that mass and matter are. Yeah. You're on the right track. So you said the word there.
What is it's always
Say it.
What is?
You got it. It's conserved, right? Very good. So in a closed system or a closed reaction, whatever, matter like mass is always conserved. All right. Y'all.
So catch
Wave 600.
Surfs up, catch a wave, 600. This is thermal energy moving from a cooler object to a warmer object.
Heat.
What is heat? He says he's correct.
I knew that. Luck.
What's up, dudes?
Name that scientist 500.
Name that scientist for 500. His name represents a unit for pressure. You said his name earlier today.
Who's Pascal?
Very good. Who is Blaise Pascal? Very good.
Pascal.
Gotta love our Pascal. All right, y'all.
I like to move it 500.
I like to move it for 500. These are Newton's 3 laws of motion. Now, you can't just say first, second, and third. You gotta tell me what is
I
first,
understand.
what is second, what is third. Are you ready?
Okay, yes. Number 1, inertia. Number 2, F equals ma.
Mhm.
Number 3 is every action has a equal
Equal
and
and
opposite
opposite
reaction.
And what's inertia? What's the first one mean? What's another way to say
It
it?
means an object in motion will remain in motion unless acted upon by an exterior force.
Boom, my friend, you have got it. That is outstanding. Very good. There you go. All right, what's up? What's up, dudes?
Name that scientist 400.
Name that scientist 400. His principle explains the concept of lift.
What is Bernoulli's principle?
Who is Bernoulli? You got it. I knew you had that one. Very good. All right, team 2.
It's electric 500.
It's electric for 500. Computer information is represented in this type of system, which contains only 2 digits.
What is?
What is binary?
What is binary is correct. They're just having the luck of the draw, huh? All right, what's up, guys? Work. 500. These are the 6 types of simple machines.
What is a pulley,
Mhm.
lever, screw, incline plane, and pulley.
We said pulley, lever, screw, incline plane.
Lever, screw, incline plane.
What did I say? Amalgam. What's the problem?
Wheel and axle.
Wheel and axle. What's the problem with amalgam? I was just saying amalgam fillings in your teeth.
Wedge.
There you go. Nice job. Very, very, very good.
It helped, but so we'll take credit.
There you go. All right, where are we going, team 2?
Surf's up, catch a wave.
Surfs up, catch a wave for 5. Okay. Ah, what's happening here?
Wait,
Oh.
the waves are going like that because of the waves add to each other.
Hmm?
No,
What do we call
the
this?
troughs are connecting.
The troughs and yeah, so what do we call this when you have,
That's a crest, that's a trough.
that's a crest and trough, but if you were to add these two waves together and you get something, what do you call it? Do you know what that's called?
Wave like?
It's a tricky one.
Not a clue.
This one is destructive interference. Because remember, if you had two waves were identical and their crest and trough lined up, then you would get constructive, you'd amplify your wave, but you get destructive interference this way. Alrighty, dude. What's up?
Name that scientist 300.
Name that scientist for 300. This man was known as a wizard in Menlo Park.
Oh my goodness. I know this. Crying.
Yeah.
Who was it in Menlo Park's in New Jersey? Who was in New Jersey?
New Jersey. The one that we watched the video, the one that was in the library. Oh, the song.
Elephants don't like him.
No.
I know what you're talking about, but I also don't know his name.
No, I forgot.
The elephant guy.
This is a big one. It's a big American scientist.
Oh,
Can we
AC/DC. Nikola
wait.
Tesla and who? Nikola Tesla and who? Yes.
Who is Thomas Edison?
You got it. It was Thomas Edison. Very good. All right, team 2.
Science matters, 500.
Science matters for 500. Matter will change from one state to another if this type of energy is absorbed or released. Ooh,
What is
Sure.
what is
No, wait, Eunice, what?
really? Close.
You say, I had no idea.
potential? I don't know. Change from
How
one
do-
state to another.
How do you get water to change state?
What is
What?
freeze? What is cold?
What kind of energy is that?
Oh, wait, no, what?
What?
Thermal. Thermal energy.
I would not have a silver.
All right, team 1. Where are we going, team 1?
I can name that scientist 200.
Name that scientist for 200. Because of his discoveries, we know the universe is expanding.
Who is? I know this person.
This is the person the last fish was named after.
Oh.
Wait, I don't know his name.
Well, this is Oppenheimer. He's the new fish, but the last fish,
Oh wait, the last.
oh, he has a giant telescope named for him now.
I remember the fish's name.
Lewis.
Who's Galileo?
Ooh, she's
said that.
wrong. Hubble. Oh no, Hubble. All right, team 2, where are we going?
I like to move it 400.
I like to move it for 400. Mass times acceleration is,
Oh.
What is velocity?
what is velocity, she said confidently?
Velocity.
Force. F equals M times A, right? If you know F is MA, there you go. All right, team 1.
It's electric 400.
It's electric for 400. When a current carrying wire is placed in a magnetic field, electrical energy, bless you, is converted to this type of energy. Ooh, this is a tricky one.
What is not potential energy?
Hmm.
Maybe.
Think about examples of when you might see this.
Oh.
Current carrying wire placed in a magnetic field, what happens?
I like your periodic table, Dad.
Yeah, thanks. So this is going to be mechanical or kinetic energy. Now, listen, I need y'all to really pay attention to this question because you have a lab practical, I told you, as one of your bonus questions. You're going to need to look at a phenomenon and tell me what's happening. So when you place a current carrying wire in a magnetic field, electrical energy gets converted into kinetic energy. So keep that in mind
Got it.
because there's a hidden aspect of this lab practical. It's something, yeah, it's something that you cannot see and you're going to have to know it's there based on what you're observing, even though there's a part of it you can't see. Like you have to look at it and know what's missing from the image, like what from the apparatus. It's there, but it's hidden. So you have to know what's there. Okay? All right. Next up.
Work, 400.
Work. 400. Work over time.
What is power?
And how would you know that?
Knowledge is power.
Because knowledge is
Yeah,
power.
it says right there.
Yes, knowledge is work over time. Very good. It's right here, right? You see
It's right
it?
there, right there.
There it is.
Knowledge is power.
Knowledge is work over time because knowledge is power.
Knowledge is powder.
Okay, what's up? Go next.
Science matters accordingly, 400.
400. An educated guess or an explanation that is either repeatable and
Oh.
supported or repeatable and rejected.
Oh, what is a hypothesis?
There you go. What is a hypothesis? Outstanding. All right, team 2.
Okay, surf's up, catch away, 400.
400.
Surf's up, catch a wave, 400. When wait a minute. I think I just clicked the wrong one. I did it. Accidentally clicked 500. Okay. No, I didn't. When combined in equal amounts. It's in here twice. Yeah. All right. Let's pick let me just say, let me give it the answer. And then, yeah, I'm gonna do it. Give me another one. I didn't realize 2 of the same on there.
Catch wave, 300.
No. 300. This type of wave is well above the range of human hearing.
Wait,
Wait, no, it's
oh,
color.
wait, it's not a color. My brother just. What is
I'm gonna lock in what is ultra. No,
what is ultrasound?
Hey, you got it. Ultrasound above the sound we can hear. All right, couch guys, what's up? Couch potatoes, let's do it.
It's electric.
It's electric for 300. This type of circuit, the kind often used in strings of Christmas lights, has only one path through which a current may travel.
Is not neon. No.
We have our 2 types of circuits that we studied. You're right, you got the right letter at the beginning. It's an S.
What is this semiconductor?
No. Type of,
No.
oh, you're so close. Series circuit, a series, as opposed to, what's the other one? It'll come up. All right, what's next?
I
300. Joule is equal to this. Oh,
You guys are getting so.
Oh, God.
Wait. What is?
What is what is work? No,
but it is work. It's the unit for work.
SI unit for joule is.
Okay. What is 5.7?
No.
What is
Newton meter.
Never
Force over a distance is work. So if it's a force over a distance, that gives you your work. So that's a joule, Newton meter, right? All right, let's do it.
It's a no. I like to move it 300.
I like to move it for 300. The tendency of an object to resist its change in motion. What's the word for this? It's also the name of Newton's first law.
Something hits going fast. Okay.
When the object you're moving back away.
It's inertia. Inertia. Very good. Potpourri, 300. It is important to conduct a controlled experiment in which only this variable is deliberately changed.
Manipulated.
There it is again. Yes, this is going to be your independent or manipulated variable. Right. I phrased the same question 2 different ways so that you can see it. But you guys know that when this question comes up, it usually is asked as like a multiple choice, but then there's also that little graphic you've seen 100 times that says, I am the controlled variable. I stay the same. I am the manipulated variable. I am what has changed. I am the dependent, whatever. Right?
Surf's up, catch a wave, 200.
Surf's up, catch a wave. Let's finish it out. Objects that reflect light are illuminated. Objects that emit light are this.
I don't know, so I'm just gonna say who is Walt Disney.
Who is Walt Disney? Carrot. Do you know? Do you know, Nico? Carrot's the answer. Do you know?
What
It's
is hammer?
luminous.
What is these nuts?
All right.
I
Good to
was
see you.
so
All right.
I was so
Work 200.
Work. 200. Forces acting this way are added together.
What is added force?
What is work?
What do you add together? Forces acting in what way?
What is
Forces acting in the same way.
In the same what way?
Direction.
Ah, good job. In the same direction. Y'all catch that one? Forces acting in the same direction get added together. All right, where are we going?
we're going science matters 200.
Science matters 200. Gravity works against this force.
What is what is what no
What is it?
what is buoy?
What is buoy?
buoy?
What is buoy?
Buoy. What is buoy do? What is no what is
What? How does it?
what is buoyancy?
There you go. What is buoyancy? You got it. Okay, volume check.
What is buoy?
Volume check. All right, are we ready? Team number 2, where are we going?
I like
It's
to
electric.
move it 200. I like
It's
to-
electric.
Wait, where are we going?
It's electric.
It's electric. Which one?
200.
200. Electrons carry this charge.
No, wait, we gotta think. I think it is, what is negative charge?
Does your team agree?
Do you agree?
No,
guys?
positive charge.
Is it positive?
Electrons. Protons are positive. Electrons are negative.
What is
Negative
negative
charge.
We
charge?
got it. Very good. All right, team number 1, where are we going?
Choose random. I like to move it 200.
I like to move it 200. The rate at which velocity changes is
What is acceleration?
very good. You knew that one.
I was
You were
gonna
like,
say, what is
boom, got it.
What is
All right.
I like to move it 100.
100.
I like to move it for 100. The speed and direction in which an object is moving.
What is velocity?
What is velocity? Very good, very good. And velocity is a?
Force.
Nope.
No,
It's
it's force.
Does it mean?
A double matter. A double bubble.
It has a
Question. No.
direction and magnitude, so it's a?
Vector.
Yes. All right. Team number 1, where we go? Yeah. Oh yeah. Team number 1.
There was a person that took me to my golf tournament and they were doing this. Oh yeah.
Oh my word.
It's electric 100.
Mm-hmm.
It's an
A device that uses electric current to turn an axle is a?
What is my chicken nugget?
What is McChicken?
What is McChicken Nugget? Oh, come on.
Wait,
A steering wheel.
No.
It's a motor, y'all. It's a motor. Remember, electric devices have motors,
Is this
whereas
the-
cars have
You should know this.
or internal combustion
Combustion
engines versus electric motors. Like they have a truck now with an electric motor, right?
I should.
You have a truck now. All right, where are we going?
Yeah.
Work for 100. Pascal's principle is at work in these systems. He knows it real good. What is hydraulic systems, or what are hydraulic systems? And our last one, team 1, you have an organized plan for gathering, obtaining, and organizing information is.
What is an experiment?
What is plan? What is what?
What is
Y'all are done. Scientific method. Get too loud. All right, so listen, here's what you need to do.
I don't think we won.
Yeah, no, right. Okay, here's what you need to do. You need to study that, and you need to study this. If you haven't already looked at this, listen up. Wait a minute. Don't be moving around yet. Pay attention. You still have like 2 minutes, so listen. You need to know these things. All right, there's your same one we just had, scientific method. Remember that these 2 questions are 2 questions that you have to memorize every exam. Find a way to memorize these 3
I'll have those
These
down.
two.
I'm being
always on every test. You're gonna have the observation versus inference question again.
Yeah, and your mom.
Right?
Not like while you're.
Conservation of energy, conservation of momentum, Newton's first law, Newton's second law, Newton's third law. Hey, guess what? Be ready to give me an example of each. Don't pull it out of thin air. Go back and look at the lab, getting tricky with Newton's laws. Do you remember that one? We had the balloons going. We were dropping little balls of paper into like cornstarch. We had marbles rolling. We had cars.
F equals MA.
No, I need an example. You're gonna have to give me an example.
Right.
So, and explain how it is. Like, you can't do this thing where you go, Newton's first law is it happens in a car accident. What part of the car accident? You're gonna need to say, Newton's first law can be observed in a car accident when a vehicle in motion stops suddenly, but the passengers continue to move forward until the restraint system stops them. That's an example, right?
A brick wall.
Right. Yeah, so you got to work on that. All of these, know these. Do them all. Do them 400 times. If you can do this and you can do Jeopardy, you will do very, very well on this exam. This one right here. Describe either of the great science smackdowns discussed in Q3. This is the Tesla Edison, and this is the Galvani and Volta. But I need the story. I don't need like Tesla and Edison argued about AC and DC. I need to know who argued for what it was about, details. The more details, the more points you get, right? Know all of these. You're going to have to label one of these. Like we did. Remember when I handed these out? We labeled them?
Yeah.
You're going to have to do that. And you're going to need to, these guys right here. There it is. You're going to label one like this. You're going to label one like this. You're going to label one like this. These are exactly, you're going to need to label these. Okay. Label one like this. All right. And you're going to need, put these on your index card. Your information on your index card is in your email, what you can and can't have. All right.
Yes.
Okay. Let's round up this other crew. All right, y'all, come on in.
All right.
Okay. Be ready. Be ready. We're going to real quick.
Okay. Can we, how about?
Just hold on. I want one thing to say before people run outside. I just want to make sure everybody's good here.